All right, today we're tackling a huge problem, one that stops so many AI projects dead in their tracks. We're talking about making retrieval augmented generation, RAG, actually work with real-world documents. We're going beyond simple text to build systems that can finally see and understand tables and images.
So let's kick things off with a question that, I swear, trips up almost every developer. You build this awesome RAG demo, right? It works like a charm on your clean little test files, but then you feed it a real document, a financial report, an academic paper, and it just breaks. Why? Why does this keep happening?
And this right here perfectly explains the problem. Over on the left, you've got a simple text file. Your RAG pipeline loves this stuff. Easy peasy. But on the right, that's reality. It's a messy PDF loaded with tables, charts, all sorts of structure. A standard RAG pipeline takes one look at that and turns it into a totally unreadable, garbled mess. And that is the gap we're going to close today.
All right, so here's the game plan. First, we're going to dig into RAG's multimodal blind spot. Then we'll get practical and cover how to decode tables the right way. After that, we'll tackle how to make our system see and understand images. Then we'll put it all together in an end-to-end pipeline. And finally, we'll wrap up with the must-know tools and the common mistakes to avoid.
Okay, first up, let's talk about RAG's multimodal blind spot. It really boils down to two main reasons your system is probably failing with real documents.
So, problem number one? It's all about tables. When you just naively rip the text out of a PDF, a beautifully structured table, with neat rows and columns, gets completely flattened. It becomes this nonsensical jumble of words and numbers. The context, the relationships between the data points, it's all gone. And that's a one-way ticket to wrong answers and hallucinations.
And then there's problem number two, images. Your standard text extraction pipeline is basically blindfolded. All that incredibly valuable information packed into your charts, your diagrams, your product photos, it just vanishes into thin air. If the answer is in a bar chart, your system will just confidently tell you, sorry, I don't have that information, even though it's staring it right in the face.
Okay, so that's the problem. How do we actually fix it? Let's move on to decoding tables the right way. It's all about turning that chaos back into clean, beautiful structure.
And this slide says it all, really. On the left, you've got that jumbled mess we were just talking about. That's what most RAG systems see. But on the right, that's our goal. It's a clean, structured format like Markdown. An LLM can actually read the table on the right and give you an accurate answer. The difference is night and day. So getting this right involves a pretty specific workflow. It's 5 key steps. First, you have to detect where the tables are in the document. Second, you extract them not as text but as HTML or Markdown to preserve that structure. Third, you handle the regular text around the table separately. Fourth, you store these as distinct chunks, maybe with some metadata. And finally, you pass these labeled chunks to the LLM so it knows, hey, this is text, and hey, this is a table. And the best part? You don't have to build all this from scratch. Not even close. There are some fantastic tools out there. Unstructured.io is an amazing open source option to get started. If you need something more specialized, you've got libraries like PDF Plumber and Camelot. And for serious, enterprise-level accuracy, you can tap into cloud services like Azure Document Intelligence or Amazon TextTract.
Now, here's another really cool technique, especially for those giant complex tables. It's called table summarization. The idea is, during your ingestion process, you use an LLM to create a quick, natural language summary of what the table is about. That summary then becomes searchable, helping the RAG system find the right table, which it can then analyze in full detail to get a precise answer. It's super powerful.
All right, we've wrangled our tables. Now let's give our RAG system a pair of eyes as we dive into making images seen and heard. So, the magic that makes this all possible. It comes from something called Vision Language Models, or VLMs. You've probably heard of them, models like GPT-4o and Claude 3. These things are incredible. They can literally look at an image, a chart, a photo, whatever, and describe what they see in plain English, just like a person would. And you know what? The workflow here is actually super straightforward. First, you extract all the images from your document. Simple enough. Second, you pass each image through a VLM to get back a detailed text description. Then, you just store that description as another chunk of text in your vector database, making all that visual information totally searchable.
And just check out the kind of description you can get. This is what's so amazing. The VLM doesn't just say, yep, that's a bar chart. No way. It pulls out the actual data. It sees the numbers, calculates the percentage increase, and notes the trends.
This is how you turn a picture into hard, searchable facts for your RAG system. Okay, so we've tackled tables, we've tackled images. Now for the really fun part, putting it all together into a complete end-to-end multimodal pipeline.
And here it is, the whole end-to-end pipeline, the full picture. It all starts with ingestion. Then you move to the crucial processing stage where you split things up. You handle your text, your tables, and your images using those special techniques we just talked about. After that, it's storage, retrieval, and finally, generation, where the LLM gets all that rich, structured context to give you a truly accurate answer.
But I want you to remember one thing from this whole process. The absolute key, the thing that makes this entire pipeline work, is that very first step, partitioning. You need a smart tool, something like unstructured.io, that can intelligently break down the document into its core components, text, tables, and images right from the get-go. Get that wrong, and the whole thing falls apart. All right, let's bring it all home. We're going to wrap up with the stuff you can use today to get a competitive edge, the right tools for the job, and the big mistakes you absolutely need to avoid.
So, if you're building this, these are the names you need to know. For that crucial first parsing step, look at unstructured.io or Llama Parse. For heavy-duty enterprise-level work, Azure Document Intelligence is a powerhouse. And of course, for the vision part, you'll be using VLMs like GPT-4o and Claude 3. These are your essential toolkit.
And look, please, whatever you do, avoid these common pitfalls. They're what sinks so many projects. Number 1, don't treat everything as plain text. Number 2, don't cheap out on your table extraction. Quality matters. 3, don't ignore images. 4, make sure you're storing metadata so you know what type of content you're retrieving. And finally, and maybe most importantly, test on real, messy documents, not just your perfect little samples.
I really want this to sink in. Getting tables and images right isn't just some nice-to-have feature. It is the fundamental dividing line between a fragile toy demo that only works in a lab and a robust production-ready RAG system that can actually solve real business problems.
Look, knowing how to build these kinds of systems, that is a massive competitive advantage right now. Seriously, most developers are still stuck in the plain text world. The gap is huge. But after this, you know the playbook. You know how to build it. So I'm going to leave you with one final thought to take back to your team, to your own projects. Your documents are already multimodal. They're already full of text, tables, and images. That's a fact. The only question left is your RAG